Hello and welcome to this final video for my SDV602 class. So for this video my intention is to do a recap on where we have been on this journey through Unity and its associated libraries and platforms before finishing up by covering things from this latest milestone. So from the beginning in Unity it was seen that the primary coding language used was C#. Others that we used, well, we used others, but C# is the only one that's really worth using. Oh, why is that popping up on me? So the way C# works in Unity is through scripts. So we use C# classes as scripts. So scripts are created using this code, and they're attached to game objects, telling them how to behave. So for instance, an example of a script would be, I haven't got it open, so let's have a look at my chat box controller. So within the C# scripts we have three main things: variables, classes and functions. So for instance, we've got another name for functions is also methods. So we have methods here, each are methods, we have variables, all wrapped up within a class. So this is a script, and notice it's got mono behavior. So yeah, the classes are a way of structuring our code to wrap collections of these variables and functions inside them. So this allows us to compare and manipulate variables. So we've got variables here, so within our methods, our functions, we compare and manipulate them, do things with them. Other examples of functions are some of the core Unity ones, such as this start, which causes the script to run on when we run a scene. If it's connected to a scene at the very start, the script will run. Update, which means it updates every single frame. We have others like fixed update, late updates, awake, which is very similar to start. And one other thing, I mentioned it earlier, so the mono behavior. So basically with the mono behavior, it's a base class from which all Unity scripts derive, only if it's to be directly used within Unity. So for instance, any script that I want to attach to one of these game objects within my hierarchy here has to have mono behavior for it to work. So that's pretty much C#. So following this explosion of C#, I'll move into SQLite. So, and with SQLite, it's storage of our game. It's basically used for storage of our game data. I'll explain more about the SQLite later on, but for now I want to focus on the programming language side of it. For the most part, it isn't difficult, as most of SQLite comes from a GitHub project where someone has created a library especially for SQLite and made it available, meaning that the only programming we really need to do is actually in accessing the library and database. So for this purpose, object classes are created. So we can see here I've created a chat, dialogue, player and story section. These are called object classes. They enable us, so each of these object classes is equivalent of a table in the database, and they contain properties that are accessed through these getters and setters. And what I really like is that the primary keys can be specified here. For instance, up here I've specified primary key, and they also auto increment, which is a neat feature, I reckon. So that's those. The other thing that SQLite uses is types. So upon creating a SQLite database, is that the one? No, actually I'm going to go to my story manager. So as we can see here, I create the database, and we're using types. So I'll explain this. for instance, this takes each of these class objects and creates a type of them to be used as a database table. So for instance, we're here, this is using the type of operator within C#. So what it does is it takes an object, our class object, and creates a type of it. It's almost like a copy of it. So in this instance we're getting types of the object classes. For the database queries, we're also using link. As you can see up here, we're using the link library. This is a query. How to put that? It's a query syntax designed specially for C#. I was doing a bit of research early on, and link is designed specially for C# from what I can understand. And which makes it perfect for querying SQL database tables from our C# program. I think that's covered SQLite, and as we move throughout the course, we also saw that we've got a local database. We also saw that we needed to move on to a server database for things like multiplier. That is where I'll move next. I'll have a look at the programming language there. So where am I? Yeah, so in this case we're connecting to our tutors one through this JSON drop service. This is a file where our tutor creates specially for us, but here we can see that it's a little bit different. We only have to create and populate our tables. All the rest of the backend coding's done. So we create and populate our database tables here, as can be seen. We create them here. The number of characters here will specify the number of characters that our fields will allow. Oh, I see I made a mistake there. It should be a few more zeros, maybe 10 or so. Anyways, here, as you can see, I'm inserting new record. How this works is this. I've got here my user as the primary key. So whenever it sees the same user, it will just automatically update that record rather than insert a new duplicate version of it, since I'm using it as the primary key. Which also means that adding and updating tends to be the same sort of a syntax here. I did find the need to use, I don't need a lot of link here like I did with SQLite, but I did use a little bit. I think if I go to my player manager, yeah, I used a little bit of link, like the dot count as a link. I do believe I used one or two more, but yeah, so not much. I did have to insert a little bit just to get the things I needed. Yeah, so however, looking at this, we can see that the real new concepts that came in with developing a server side is actually the delegates. So when adding or manipulating data, we have to pass all the handling of the output to a delegate here. So they're useful in that they allow methods to be passed as parameters and defined, and they also define callback methods. So here we can see that I'm using my login here, passing my username and password here, but then I'm getting my query, but it's not doing anything with it in this method. Instead, it's passing it through my delegates, which are essentially methods passed within another method here, but as parameters in this respect, which is what a delegate does. And then we can see the delegates in use here. Each delegate does something on the data, does something on the previous method's data. The easiest, also the other thing I noted is delegates almost work. For instance, here these delegates are working almost like a boolean, true false. For instance, this one here, if this select statement doesn't return anything, it will return this delegate will run. If it returns something, this delegate will run. So in my thinking, it's almost like a true false, and I treat it as such with how I executed my code here, or wrote my code. It's delegates. For the next stages, so that's mostly the program languages I think covered. For the next bit, I want to look at the architecture of our platforms. So first one, I'll start by looking at Unity. As a platform, I find Unity to be quite intuitive to use. There is a project pane, for instance, here. This displays all files used in the project. It also includes things like assets, scripts. So scripts are here. Got assets up here. We've also got our scenes, and we've also got materials, and yeah, the game assets. Yeah, so it covers pretty much everything there. And so on opening a scene, for instance, I've got the login scene opened. We've also got the hierarchy view, and this is where all the game objects within this scene are kept, including things like canvas and items on it. Yeah, so it includes things like cameras, the managers, so the empty objects like the manager, which hold scripts, event systems, so canvases, cameras, lighting, quite a lot of things. And talking about canvases, these are a very important part of the software, as these are where all UI components are manipulated from and displayed on screen. So here we can see this is my canvas here. It's got all the UI components for my login screen. Here, this canvas allows them to be manipulated and displayed. We can see there's examples like buttons, images, text drop, and I haven't used them, but there's also drop downs, etc. Within Unity's platform, there's 4 other areas I would like to look at. First one is Inspector, so that when I look at individual objects, the Inspector allows me to manipulate them. So, and also I can use a drag and drop feature, so I can drag and drop scripts within the objects, which makes for very easy usage of Unity. Other areas are the scene view. This basically is this is where I can manipulate my environment, and the game view is where I can see what I'm manipulating, which is quite nice. And the console is where all logs are kept, including errors. And the last area is the build settings. So this is where we build a project, and to build a project we also need to set the scenes in the build and the order in which they'll appear in the build. So scene 0 is the one that will show up on game launch. And also can be seen in this file folder structure here is MVC, model view controller. I sort of bought on model view controller. I'll touch on model view controller. So if look at MVC in my scripts here, we can see that the player manager, so my managers are the models, so they aren't mono-controlled. They are actual core model scripts, and they allow me to manipulate data. They contain all my database accesses, and then that's used to manipulate the data coming in to and from the database to the objects. For instance, I've got a player manager. That allows me to manipulate all data that pertains to the player itself: username, login, XP, scores, health, things like that. We've also got the views, which is these scenes. They allow me to see what's on the screen. And we've also got controller scripts. So the controls almost like the go between the view and the model. They allow me to control how these models act and how they display stuff on how it controls what they do on the screen. Um,